My first day's training concludes with a grueling theory exam taken in a dark and oppressive classroom.
Well, how do you say hello underwater if you can't do that? That?
Well, actually, that means moray eel. This is octopus.
Yeah.
This is turtle.
What shark? Oh, it is? Yeah, like a fin.
Yeah.
Shark.
And big shark.
So you go... That means, look out, shark.
I'm out of air.
I'm out of balls.
I passed my exam with an impressive mark of 94%. Next day, it's time for the real thing. And now my gorgeous pouting instructress, Danielle, is going to take me out there in the real ocean to do some safety checks and all sorts of other things to ensure I won't drown before the shark eats me. Any sharks?
Sharks have been known to hang out in these areas.
Is it too late to change my mind?
Yes, it's very much too late. It's now or nothing, man.
I put my gear on and leap into what I hope won't be shark-infested waters. Underwater, I discover a pleasantly shark-free environment. Down on the seabed, Danielle tests me on a series of emergency drills. Then we explore a shipwreck. Okay, it's just a little sunken fishing boat, but Jacques Cousteau had to start somewhere. Half an hour later, I surface, undrowned and uneaten. It's fantastic. I know you guys see fish all the time, but those blue ones and those yellow ones are just remarkable.
Yeah?
You swam right up to my face and spoke to me.
Oh, what did he say?
Something really fishy. I'm now a qualified diver. That could have attracted a shark, couldn't it?
Yeah.
It's a good job we got out. Otherwise I'd have no leg at all.
Right.
Back on dry land, I begin to wonder whether a shark could really have detected me that easily. The great thing about Jaws the book is that the author, the late Peter Benchley, gave you a lot of information about how sharks work, and it was all stuff you didn't get in the film. Here's a bit from near the beginning where the woman gets eaten. 100 yards offshore, the fish sensed a change in the sea's rhythm. It did not see the woman, nor yet did it smell her. Running within the length of its body were a series of thin canals, filled with mucus and dotted with nerve endings, and these nerves detected vibrations and signaled the brain. The fish turned towards shore. Scared? I am. Benchley was describing an extraordinary mechanism in the shark's arsenal of senses called the lateral line system. This enables sharks to detect the vibrations of another animal in the water up to 100 meters away. Now, I think I need to speak to someone who knows all about this special shark sense.
I'm on.
Good morning.
Captain AJ is a spear fisherman. He works in the heart of shark territory and hunts fish with a spear on a catapult.
And you pull back, just like a big slingshot, and you're following your prey. Once you let go, the spear is gone.
But the vibrations from a speared fish can act like a red alert for the shark's lateral line system.
The problem is the body and the tail starts beating on the side of the spear. And right, the shark senses a sick, wounded fish, easy prey.
So this is all their sensory stuff coming into play now?
Correct. They're going to pick that up, and they can also sense approximately a teaspoon of blood and approximately 100,000 gallons of water. You're literally ringing the dinner bell.
Now that's worrying. As well as detecting vibrations, sharks can home in on the blood from one knee wound in a whole ocean.
When you speak to boffins and sort of shark marine biologist people, they always say that actually sharks are completely harmless. They're not interested in humans at all. Would you agree with that?
I'd like to have them come out and dive some areas around the Bahamas with me and see if I couldn't change their mind, because after 30 years of doing this, I'd really have to disagree.
Captain AJ never drops his guard when sharks are in the vicinity.
You never know what they're going to do, and if you become complacent, they're actually going to come in and bite you. I had a tiger shark come down on me where it was getting so close, you can literally see the teeth sticking out of the gums. It's really intimidating having this creature that's probably 1,500 pounds coming at you.
Yeah, brilliant.
So, not only do sharks have fantastic mechanics, but it turns out they have an amazing sensory system as well. Apparently, sharks can detect electrical fields as weak as 5 billionths of a volt, which is extraordinary. And cunning too, because it helps the shark to find fish hiding in the sand. But what about the electrical field that I'm giving off? If I'm in the water with sharks, could they detect that? This has given me an idea for an experiment. I just have to ring room service. Hello, room service. Oh, excellent. A lovely, fresh, human biometric activity interrogator and some lager.
There we go, sir.
Thank you. And are these my boffins?
They are indeed.
Superb work. Thank you. Look here, have a shilling. These two boffins are in fact biomedical engineers, and they're wiring me up to the catchily titled Human Biometric Activity Interrogator. Now, this may look like some sort of torture device, but actually there is no electricity rushing through these electrodes into my body. It's actually going the other way. All this kit is measuring the electrical signals that I'm giving off. My muscles and body organs all produce electricity. The heart emits a constant pulse, and even just a tiny movement of my eyeball sends out a signal. If I clench this arm muscle, like I might do if I was swimming along, you get a signal as well. That's the sort of stuff that sharks will pick up. That's remarkable. I'm typically giving off just 1/4 of a volt. Could a shark pick that up? And if it can, how? We can't do that after all. My selfless quest for even greater shark knowledge has brought me to the small, wet, grey and notoriously miserable island of Bimini. Dr. Samuel Gruber is the top shark scientist in the world. He's been studying these creatures for more than 40 years and understands their senses like no one else. What's the thing that really does it for you about sharks?
I look at a shark and I see something perfectly honed by millions of years of evolution. Aquatic animals are living in a constant haze. It's like if we were walking around in a fog. Well, you should know about that being from London.
I knew that was coming. Why did I know that was coming? Yes, the old pea super.
Exactly. If they're going to be super predators, they have to be able to get through that pea soup with other sense organs.
Before I get into the water with some sharks, I want Dr. Gruber to show me how their electrical detectors work. Now, you and I have cuddly dogs and cats as pets. He keeps baby lemon sharks. Now, the shark doctor and his assistant Steve have brought me out to this special pen where we're going to see just how brilliant these sharks' prey detecting senses are.
Sure. What we want to show here today, demonstrate, is the phenomenal electrical sense that these guys have.
Steve is burying 2 tubes in the middle of the shark pen. Some smelly fish blood, coloured with pink dye, will be pumped through one. Through the other, a tiny electrical current will be conducted into the water. This electric field is the equivalent of what, say, a small fish would give off.
Yeah, the amount of electricity is hesitatingly small, in the order of a billionth or less of a volt per centimeter. That's a B, billionth with a B.
First, the fish blood is pumped into the shark pen. The shark's acute sense of smell is immediately stimulated.
You see how the sharks go to the pink? Now, turn the electric field on.
Suddenly, the lemon sharks turn away from the fish blood and start biting at the area where the electrical current is being transmitted.
That's it. The sharks moved away from the pink blood and onto the clear electric field.
That's amazing. The shark's incredibly receptive electrosenses attract them like a moth to what they see as a bright flashing light. But where exactly are these receptors on the shark's body?
Oh, he's actually going to pick it up.
Within moments, the doc expertly calms this frisky lemon shark by putting it into a kind of trance.
All you do is turn them over, like so.
Why's that?
Well, they go into a state called tonic immobility. Their senses get mixed up. Up is down, down is up, and as a result, they go to sleep.